Have you ever found yourself stuck trying to invert a matrix, only to realize there are no packages that can handle it in fraction form? It can be quite a headache, right? Well, today we're diving into how to perform fast matrix inversion without relying on any packages. I totally get it. Working with matrices can be tricky, especially when you're using specific data types like the fractions from the GMPY2 library. You're not alone in this struggle. Many developers face similar challenges when trying to manipulate matrices in Python. Let's take a closer look at the question at hand. One user asked, is there a computationally fast algorithm that I could use to calculate the inverse of a matrix? They specifically mentioned using the MPQ class from GMPY2 and the need to keep everything in fraction form. Sound familiar? Let's explore some solutions together. So what's the issue here? The challenge arises because most libraries that handle matrix inversion don't support the fraction types you're using. This means you'll need to implement your own algorithm, and performance is key. Let's break down some efficient methods you can use. And stick around. I'll share a powerful algorithm at the end that can significantly speed up your matrix inversion process. You won't want to miss it. To begin inverting the matrix, the user should first define the matrix M using the MPQ class from GMPY2. This allows the user to work with fractions directly. Next, the user should implement a function to perform the matrix inversion. A common method is to use the adjugate matrix and the determinant. The user should also create a function to calculate the determinant of the matrix. This can be done using recursion for smaller matrices. Finally, the user should test the inversion function with a sample matrix to ensure it works correctly and returns the expected results in fraction form. Fun fact, did you know that the concept of matrix inversion dates back to the 19th century? Matrices have come a long way since then, and now we can manipulate them with just a few lines of code. Now, let's look at the answers provided by other users. An alternative approach suggests considering the properties of your matrix. For symmetric positive definite matrices, using Cholesky decomposition can provide a faster inversion method than the Gauss-Jordan method. For general matrices, the Strassen algorithm is faster than Gauss-Jordan, but slower than Cholesky. If exact results aren't necessary, there are faster algorithms for approximate inversions. Additionally, it may be worth evaluating if you truly need the entire matrix inverse, as sometimes leveraging other matrix properties can be more efficient. Here's the powerful algorithm I promised. Consider implementing Strassen's algorithm for matrix multiplication. It's faster than the standard approach and can help speed up your inversion process significantly. And there you have it. With these methods, you should be able to invert your matrix efficiently while keeping everything in fraction form. If you found this video helpful, don't forget to subscribe for more tips and tricks on programming.